Alright, so welcome back to our channel, the Sips Peters TV. Today, the second engineer called me to have a look the compressor number 1 because during the routine visual inspection to the crankcase, they found some raw materials or like fine powder or look alike grinding paste. Then he asked me if I had an idea for where it is coming from, this fine powder. So I tell him that this metal content mixed with the oil from the samtang came from the worn out parts inside the compressor. So if you try to continue starting this compressor, it will be terrible further damage. So the second engineer talked to chief engineer to ask permission to dismantle and parts out this compressor so that it will be figure out which parts of this internal parts of compressor is damaged. So by this grinding paste or metal content found inside the crankcase, and it is a sign that there is a turbo problem inside. So we try to dismantle this compressor in order to assist or figure out which part of this internal parts of compressor has been damaged. So after taking out all the internal parts of this compressor is SPERRE compressor. The maker is SPERRE. So first thing to do is to taking out this impeller pan. This pan is used to cooling the whole body of the compressor. And then the second one is the counterweight. Before that, you must to loosen this Allen bolt attached to the shaft. And then when you push out by the use of these special tools and try to rotate in clockwise, but during the process must be careful because when the counterweight is falling down and catch your hand in the edge of this body, because this is conical, once you push out it will be falling down suddenly. So this counterweight has around 10 kilos, and pulling down and catch your hand here, so it will be severe problem. So before that, you must to fix the counterweight holder just in case if suddenly falling down, it might be held by the counterweight holder. And after taking out all the parts, we found out here some metal content, and also we found out the connecting rods surface is also damaged, so the appearance is very rough. And during the taking out this bearing cover or spacer, we figure out that this part is already totally damaged. So since we don't have on board this kind of spare parts, so we try to make it new one by our own. So these two spacer or bearing cover cannot be changed each other because of have different sizes of their holes. Here is small and the other one is big, so cannot be changed each other. So I try to make it the new one to replace this damage. So as of now, I try to look for materials for this kind of spare. So I found that this material seem like ordinary metal. So I decided to use hot roll metal plate is good enough to make it seem like this, because the materials is look like seams with hot rolled metal plate. By the use of plate machine, we can do it seem like this, but during process must be careful the outside diameter and the inside diameter and the thickness, and also must be very careful during machining, drilling, and measuring. Be sure that all the details and measurement of these old spare parts that will be exactly 99% to the new one that we make it. Because once you make mistake, even 2mm or 1mm, it will not be fit there in position. So your effort of the day will be useless. So that's why I recommend that every angle, every measure must be very carefully, because once you make it mistake, then the time and the effort is useless. So now try to look on my video on how I make it and machining this kind of spare, because we don't have any spare on board. Watch this.
Ito po ang channel ng Ships Peter TV. Ako po ay pusong nagpapasalamat kung maklik ninyo ang subscribe button sa baba.
And now I start fabricate the bearing cover or spacer. This spacer is attached to the aft counterweight. As you seen there, what I'm doing is to make it center, and then afterward I cut by acetylene. Before that, I make 5mm bigger of the original size of these compressor parts, so that I can make adjust during the machining process. So it's better to little bit bigger, so that we can be managed during machining in the lathe machine. Whereas if you are little than the original one, that is the big problem. So it's better little bigger than little smaller. So that's why I make allowance about 5mm or maximum 8mm, so that it will be easy to manage during machining. So that is the secret when you make machining spare parts or any parts that you make it on board. First thing to do, I make welding this small plans in the center, so that it will be catching the lead machine jaw during the tightening, because our lead machine is not capable the diameter of this big plans. So I try to welding a small plans in the center so that it will be easy during machining process in the lead machine. So after this heavy welding, see to it that your welding in 4 points must be strong enough so that it will not be flying during rotation of the lead machine. And you know, if you not make good this welding, it will be flying and hurt somebody or hurts you during rotating. So now this is the original one that I make it there. Then the small plans that I welding is little smaller. So now I try to cutting these plans so that it will be faster machining in the lead machine. So as you notice that I cut this plate is start stop so that it will be not curve the plates. So now after cooling these plates, so I try to fix in lead machine. So now I start machining and watch this video. So during machining, all the loosened parts must be secured and wear the face shield so that the chips, flying chips, not hit your eyes. And then try to use some other PPE for your own safety. So here is the final dimension. The outside diameter is around 149.540 millimeter, and the inside diameter is 87 millimeter, and the thickness is 8 millimeter. So we try to follow this dimension so that it will not be causes any problem during box up. So now I try to final the inside diameter around 87 millimeter. So the liquid that I drop to my tool bit is cutting oil. So the cutting oil is the suitable of the tool bit during machining to prevent further damage the tool tips. So if your tool tips is damaged, so the output of your project is not so smooth. It's like a rough surface. So to prevent that one, must be all the times you must to drop and cutting oil. That's why all the time I drop my tool bit by cutting oil. During machining, the inside diameter time to time must be measured. So every feeding is only 1 millimeter or 0.5 millimeter, so that you can control the exact inside diameter of this compressor spare. So as I told you before, that must be time to time to take it measure. after this must be continue in part 2, so don't be escape in part 2 so that you can see the whole process in my project of this SPERRE